Alright guys, up next we have Róman Joost, who currently works for Red Hat, and he's here to tell us on how to build a program slicer. Róman.
Thanks a lot, and thank you for listening to my talk. So this is a story about how to build a program slicer. Perhaps just quickly about me. I currently work at Red Hat. I formerly was dabbling in the web apps sphere in Python, building web apps with Zope and Plone. Yeah, and also contributed to GIMP. So the whole graphics scene was a little bit, and GNOME scene was a bit of my home. So this talk is leaning towards more the how to get there story rather than the technical aspects, even though I can have something to show for. So the talk is about educational projects and how to get to something where you actually have no idea of. And for educational projects, obviously, the primary purpose is the learning experience. And the great thing is, with learning experiences, they are on ship dates. So from my talk, I thought we quickly come to the takeaways. And that is, first and foremost, find a study topic, build a tool to help yourself, and keep a diary. So do the first, find a study topic. And perhaps a little disclaimer, I come to the intricacies of what program slicing is and what it does throughout in my talk, so please bear with me. Let's talk about a study topic. So the study topic should be something which is out of your comfort zone. So picking, if you're a Python programmer, maybe picking Ruby as your study topic might not yield a lot of an educational gain, since they're almost similar. So pick something you have never heard of and you find interesting. The tricky part is, so watch out, you can easily get sidetracked with that. So once you explore a different problem space, you will find lots of tools who also tried something like that, and exploring them might get you down into the rabbit hole where you might never come out of. So for me, the study topic was something I didn't sort of think about in the shower, and I thought like, hey, let's build a program slicer. In the previous company, I was working with a lot of junior programmers, and some of the things I was stumbling over was this book. So I ordered this book and basically read it, and in the book was, the book basically gives you an overview of how you can debug systematically programs. And one chapter is about static analysis and how you can reason about programs just by basically looking at the code. And in there, the author was also introducing program slicing, and which brings me to the motivation, basically. What is program slicing and why would you want to use program slicing and things like that. So when I talk about reasoning, then in a way we all do it as engineers because we have to understand the code we are working with, right? But when I talk about reasoning, I'm not talking about Sherlock Holmes reasoning. It's more like, you know, looking at the code and try to understand, distill what states the different statements are in and what it does. So, as an example, I'm not referring here about correctness of the algorithm here. It's just the source code fragment. So, people who have implemented prime number generators might see that the code is wrong. But anyway, what I'm getting at is these are a few lines of code, and if you wanna reason about, for example, the primes variable. It's a list, right? So it gets appended to and gets returned at the end of the function. Another example, but this one is more inferior to the previous example. So now looking at what primes does and potentials does and all these lists, and they're going to a while loop and then mix and match. So now figuring out what primes and potentials are doing is probably a bit more difficult. Another example, I took it out of the internet, but the point here is the more complex the programs get and the functions get, the harder it actually is to reason about them, to figure out which statements are interfering with each other and which statements you can basically ignore. So if I quickly go back to the examples I just showed you, it would be much easier if we could sort of highlight what depends on each other. If you guys know Vim or your favorite editor, you can probably highlight all the same variables, but highlighting what is dependent to these variables would be really cool. So the example again with highlighted variables dependent to each other, that's way easier to figure out what's happening here than just by looking at the code itself. So that's kind of the formal definition of what program slicing does. But what it really basically comes down to is just highlight or show me everything what I need to know, and which depends on a statement I'm interested in. And now that brings me to build a tool for yourself. So understanding what program slicing is and what it can do for you, that's a cool thing. So I thought when I was going to swath of Python code and I had to think about what the hell's going on there, I thought, gee, that is quite a tedious task. Now, when I discovered program slicing, I thought, that's a really cool thing. I want that. Turns out that for Python and for dynamic languages, this tool doesn't really exist. So I had to build one for myself. And one of the things I usually do is I do some homework and figure out if tools in that problem space already exist, and if they exist, what problem do they solve? So one of the things is always good to figure out if the tools already exist and fix a specific problem, because you don't want to reinvent the wheel, and if you reinvent the wheel, you want to know why you're really reinventing the wheel to solve, let's say, a different problem. Yeah, and what problem does it solve? So that basically brings us, when we talk about an unknown problem space, building little prototypes to explore different directions into that problem space is a really good thing to get sort of started and a little sort of a success story into it. Because when I looked at the official definition of how to program slice, it talks about control flow graphs and dependency graphs, and even though I had a formal understanding of what graphs are, creating control flow graphs and data flow analysis and stuff like that, never done that before. So I thought, crap, how do I do this now? So that brought me basically to a first Python program, or my first implementation. And with my limited understanding of a graph, what I basically did, I tracked names and variable names among the source code. And I know it's really small, but I'll show a quick demo in a few minutes. Basically what it did, in your favorite editor, you just press a button and it highlights all the additional source code lines. But that was highly dependent on the code I was looking at. So I couldn't sort of slice methods or classes or whatever. So the interesting thing, though, that it gave me already an instant tool to employ when it worked. But it obviously had problems. So I didn't create a control flow graph to sort of systematically map that over source code and source code fragments, which would have been yielding better results. And the motivation to improve that program, due to the fact that it sort of gave me already a quick benefit, sort of was gone. And I actually didn't look at the tool for over 2 years. So back at Kiwi PyCon last year, I think I had a bit of time at my hands, and I sort of looked at a second attempt of hacking it. And this time I tried to improve the graph itself. Let me give you a quick demonstration of what it actually does. So basically what you can do is you can now see what variables are depending on A. I mean, that's sort of almost obvious here in this example, but maybe let's take this example. So, so that kind of works as in it doesn't crash or it doesn't fall down, but there are obviously problems. So I'm still not constructing a control flow graph. I'm still not doing any data dependency analysis, anything. It only works with Python. And if you want to slice anything more complex, it sometimes doesn't work, yields false results. So it's kind of, if you would think of it as a product, it's not suitable at all. It might work for me, but probably not for anyone else. Which brings me basically to the next topic. So I had the ability or the chance to learn more about graphs on a Coursera course. So now I knew, right, there was something with graphs. So there are directed graphs, there are undirected graphs, there are acyclic graphs, et cetera, et cetera. And there are implications to how you want to represent your source code, et cetera, et cetera. The other thing was also I started to study Haskell. And Haskell brought in a new paradigm of thinking. And when I studied Haskell, and I thought the tricky thing with learning a new language is basically you need to employ it, you need to apply it. And with the functional language, it is really hard to get directed acyclic graphs right. So here I went into basically employing a library which is being used in the compiler for data flow analysis and creating control flow graphs. So I thought if I might not get the graph correctly represented, better to use a library and go from there, basically. And when I looked into that, compilers, right, there was something, I thought, because compilers need to do that all the time. So colleagues actually gave me an idea of looking into LLVM. Maybe someone has solved the problem already, so I could basically save the time and just use a different tool. But unfortunately, from what I've so far discovered is that the motivation for all of these tools to create control flow graphs and do program analysis is because they're transforming your source code into an intermediate representation, into other source code. And doing all this analysis is basically how you want to eliminate unwanted statements and stuff like that. So it actually does the right thing, but it doesn't work on your source code. So it works on something down the line to machine code. And here comes the other thing. When I used Haskell, the tricky thing is I felt I'm really going down the rabbit hole here with different languages and stuff like that. How do I measure progress? And that's basically point 3, keep a diary. The thing with diaries, though, it feels a bit like if you read your own diary, and in order to distill the progress out of that diary, it's a bit tricky. It feels a bit like, you know, playing with yourself. So but that's one aspect for a diary, one benefit for a diary. But the other thing with a diary, it is actually a really cool rubber duck. Who of you guys know what rubber duck debugging is? So just to quickly explain it, you probably all were in situations where you basically, for a problem, you hit the wall with the solution, right? And you couldn't really figure out how to go from there. You've searched all possibilities and nothing seems to be working. And what you do usually is you say to your colleague, hey, come over here, can you help me with that? So what you do is, to your colleague, you explain, look, this doesn't work, and I've done this and this, and you basically explain what you've already tried, and by explaining to him, you come to the realization, hang on a minute, I haven't tried X, Y, Z. So your colleague is basically the rubber duck because he didn't help you at all finding the other possible solutions. You could also do that to a rubber duck, right? Because you don't really need someone to stand there. All you need to do is explain what you've done. And with the diary, it basically acts as the same thing, but it just looks less ridiculous because you don't have to talk to yourself. And the other thing is also that you could write down what you want to focus next. I have a family, and I can't employ much time on that. So usually it acts like a good way of a stack. So you put down, okay, next time when I work on this, focus on this particular thing. Future plans. So as I said, with educational projects, you really don't have the aim to produce a product, but you want the tool which helps yourself. So it's still, for me, the motivation is there to sort of enhance it further and maybe build a product out of it. Maybe language independent would be a cool thing. At Red Hat, I'm not only working on Python code, also on other languages. So having something in language independent, that would be a nice thing. And currently I'm working on basically implementing the proper slicing model of creating control flow graphs, doing data flow analysis and stuff like that. That is almost about it. People who are interested, please come to me. People who might know Python tools or other tools who already do that, please come to me. I wanna know about it. You can most likely find me on the nick Romanovsky on the internet. And thank you for your attention. One thing what I wanted to say, Redhead Brisbane is hiring, and who is interested in a Python software engineering position, please talk to me.
Thank you, Róman. We have some time for questions if anybody's interested.
Have you looked into SSA-based approaches for your program slicing?
No, not yet. SSA-based. Cool.
It's a much, I guess, cleaner way of thinking about control flow graphs.
Okay. Yep. Maybe we should have a chat about it. Sounds cool. Want to know more about it.
Anyone else? Oh.
Thanks, Róman. Great talk. I'm just wondering, the plugin that you have written, is that just for Vim?
Yes. Well, it's sort of really a prototype since I've
Yeah, cool.
spent more time on the Python program.
Awesome.
It's only for Vim, even though I'm sort of switching back and forth between editors. But yeah.
Cool. Now, I think looking at that, as someone who doesn't code very, a great deal of my work time, I think that's a really good process to get into, to be able to actually quickly look over code, see what's related to each other, because we obviously do spend a lot of time looking through code, and looking through code that we don't actually write ourselves. So it's good to, it's really cool. Thanks.
Yep.
Have you looked at any of the tools that PyPy could give you in terms of language understanding?
Yes. So I looked at MyPy, for example. I looked at Pyland. Nick Cogling helped me there to give me a few pointers. They helped me in terms of understanding how other people solved building control flow graphs. As I said, the tricky thing is that they usually do that in a transformation of the source code, so mapping that back into your original source code. That's a tricky thing.
Would that apply to the underlying LLVM, and then you get the cross-language support?
Yeah, I looked at that.
Yeah,
I looked at that. That's exactly the problem I faced. Basically, if you end up, or at least that's my understanding, if you end up with the intermediate representation, then I saw you could map it back into Python code, but that not necessarily is the same. So, yeah.
We still have time if anybody else is.
You can store the lines, like, sorry. You can store the lines of your original source code in the nodes of your tree, and then you can just recompile from there, right? So that's not really a problem.
Okay. Well, let's have a chat afterward.
Alrighty. Thank you, Róman.
You come to me. Just.
Hey, thanks for the chat talk. As someone who works with embedded systems and things like that, as an electrical engineering student, any idea if this could work with interrupt-driven like environments and things like that?
No.
I'll chat later.
Yes. Yeah, that sounds interesting. Yeah. Cool.
All right. Thank you, Róman.
Thank you very much for listening. Thank you.